Alright, for this problem it says find the value of y so that the line passes through the pair of points has the given slope. So basically they're giving you 2 points, but the situation here is that one of the points is actually has a value missing, and that value that we're looking at, that we're trying to find, is y. So the other key thing about this problem is that they tell you that the slope is 4. So if you remember, to find the slope, it's the change in y over the change in x. So this is going to be y2 minus y1 over x2 minus x1. So if I set this up, this is my x1, y1, x2, y2. So this is going to be y minus 5 over 1 minus 0. But the key for this is that we have to set it equal to -4 because they already told us what the slope was equal to. So we're going to simplify this. So we have y minus 5 is equal to 1, or over 1 equals -4. And we're going to solve this equation. So in solving this equation, we're going to multiply by 1 on each side. And we should recognize that multiplying by the 1 is not going to change anything for us. So we have y minus 5 equals -4. Add 5. And y equals 1. So again, when given a problem like this, you set it up just like you would any slope problem. Set it equal to the slope that they are telling you it is, and then solve the equation. Alright, for the next one, it says find the point slope form of the equation. So point slope form is y1, So it's y minus y1 equals m times x minus x1. Point slope form is just a different format so that you can actually plug a point in when given a point and a slope. So in this situation, I've been given the point and I've been given the slope. So my y1 is -4 and my x1 is 1. So I'm going to plug that information in. So it's going to be y minus -4 equals m, which we know is -7, times x minus x1, which is 1. Alright, and it says type your answer in point slope form. So we're just going to simplify this, and it should be our final answer. So y plus 4 equals -7 times x minus 1. And the answers that you're seeing here, I just took screenshots, so you can go back and see the answers that you typed in, but the ones that are given here are the correct answers. So just keep that in mind. So next problem says find the slope-intercept form. Now slope-intercept form is just y equals mx plus b. So slope-intercept form is simply using the slope and the y-intercept. So the key for this one is we're going to have to use these 2 points, and we're going to use those 2 points so that we can find my slope. And then after we find my slope, then we're going to use those 2 points and find the y-intercept, which is the b. Alright, so we're going to start with slope, and we're going to use our y2 minus y1 over x2 minus x1. And I have y2 is going to be 3. Minus y1 is 6, divided by x2 is 2, minus x1 is -4. Alright, so I simplify. I have 3 minus 6 is going to give me -3, and 2 minus -4 is going to give me positive 6. So if I simplify this, I should get -1/2 as my slope. Now, I'm going to use, to find my b value, I'm going to use the slope, and I'm going to use one of the points. So use your slope and 1 point, and you can plug in that information to find your b value. So I have y equals mx plus b. I'll just pick the first point or one that looks the easiest. It really doesn't matter because you should get this, or you should get the same answer if you did it correctly. So I'm going to use -4, 6. So this is my x, this is my y. So in the y spot, I'm going to plug in 6. And then I have negative 1/2. In my x spot, I'm going to plug in negative 4 plus b. So I've plugged in everything I know except for b, which is what I'm trying to find, and that's what I'm going to solve for. I've basically created an equation to find b. Alright, so I have 6 and negative 1/2 times negative 4 is going to be giving me 2. And then I'm going to solve for b by subtracting my 2, and I get b equals negative 4. So I'm going to take what I know. I know my b is 4, my slope is 1/2, and I should be able to write the slope-intercept form is y equals negative 1/2 x plus 4. Alright, so the next one, it says find the value of x and the value of y for which x, the point x11 and the point 10y are points on the graph. So really this is just a basic substitution problem. I'm going to take what I know, and I have the equation 3x plus 4y equals 26. And I'm going to plug in and find what x is. So I know my y is 11, and I'm going to plug that in the equation. So 3x plus 4 times 11 equals 26. Alright, so that's going to give me 3x plus 44 equals 26. And then from there, I'm going to subtract 44 from both sides. And that's going to give me negative 18. And then divide by 3. So my x is negative 6. Same thing for the other point, except for this time they've given me the x value. So I'm going to do the exact same process, but I'm going to plug in 10 for x. So this is going to be 3 times 10 plus 4y equals 36. So that's going to give me 30 plus 4y. I'm going to subtract 30 here. And 4y equals 6. Alright, so I just realized that I copied the problem down wrong, so I'm going to backtrack for a second. I was wondering why it wasn't working out. So actually this is going to be 26. So at this point, if I take 26 and subtract 30, that's going to give me negative 4. Divide by 4, and y equals negative 1. Okay, and as always, I could graph these in Desmos, and I'll create a video in just a second to send to you as well. But basically, if I'm looking at Desmos, I could easily graph this equation, and then I could go look and try and find these points and see where they actually are intersecting. But again, I'll show that in just a little bit. The next one, for the given point on the line, find the equation for the line that's passing through the point and is parallel to the given line. And then they also want to find one that's perpendicular. So the key for these for parallel and perpendicular is parallel lines have the same slope. So you got to remember parallel means same slope. And perpendicular lines are going to have opposite and reciprocal slopes. So opposite reciprocal slopes basically means we're going to flip it and change the sign. So opposite reciprocal. So flip and change the sign. Okay. Alright. So we have the point, we have the line. Great thing about this is it's already in slope-intercept form. So I can tell you what the slope is initially. So my slope of the initial problem is 6. Now when I use these two parallel lines, so that means parallel slope. So the lines that are side by side means parallel slope. So if my original slope was 6, my parallel slope is the same, which is also 6. The upside down T means perpendicular slope. So we're going to flip it and make it 1 over 6 and change the sign to negative. So we're going to use those slopes, and we're going to use the point, and we're going to find our B value, our new B value. Because they're asking us to create the parallel line that goes to that point and create the perpendicular line. So we got to find the B value for parallel. And we got to find the B value for perpendicular. So we're doing two processes here. Alright. So parallel, we're going to take our point 7, 1, and we're going to use our parallel slope. So we're going to use those two pieces there. And we're going to plug it into y equals mx plus b. So my y value is 1. My parallel slope is 6. My x value is 7 plus b. So we now have 1, and we have 6 times 7, and that's going to give me 42 plus b. We're going to subtract that 42 and solve for b, and we now have b equals negative 41. So my parallel line has a slope of 6, because it should be the same, minus the y-intercept of 41. So that's the parallel equation. Now we're going to do perpendicular. So with perpendicular, I'm going to use the same exact point, because that point still matters, but now we're going to do perpendicular slope. So we're going to do 1 equals, and we're going to do negative 1 over 6 times 7 plus b. Alright, so I have 1 equals negative 7 over 6 plus b, because when we multiply 1 and 7 together, that's what it's going to give me. So I'm going to take 1 and I'm going to add 7 over 6. And you are not expected to do this by hand. You can put it right in Desmos and get the fraction. And b is going to be 13 over 6. So my equation, I'm going to use my perpendicular slope, is negative 1 over 6x plus 13 over 6. And there's my perpendicular equation. Alright, so the domain of finding a rational expression. So when I'm looking at the domain, I'm always going to look, especially when I have a rational expression, I'm always going to look for what's in the denominator. Because when we do a rational expression, the denominator, so if I have the numerator over the denominator can never equal 0. It's just that simple. A fraction, a rational expression, means part out of whole. So I can't take a part out of 0 because there's nothing there. So we always have to remind ourselves that domain can never equal 0. So when I'm looking at my domain, I have two parts. I have x plus 7 and I have x minus 4. So I need to figure out what can x not be equal to in order for it to not be equal to 0. So x plus 7, if I subtract 7, x can't equal negative 7, because if I have negative 7 here, negative 7 plus 7 would equal 0, and we don't want that to happen. Same thing here, I would add 4, and x can't equal positive 4, because 4 minus 4 would equal 0. So if I look at this on a number line, so I'm not even looking at the main graph, I'm just going to look at it on a number line. So I'm saying that it can't be equal to 7 and it can't be equal to 4, but it's going to include everything else in between and around. So when I read the domain, I read it from left to right. So I'm starting from the left, so we're coming from negative infinity, and we're going to stop at 7. There is a open circle there. It can't include that. Or technically, it's going to be an asymptote, but the value of 7 is not included. Or excuse me, negative 7. Alright, now I'm going to pick back up, so I'm a union. So I stopped on one side of negative 7, not including negative 7, and I'm going to pick back up on the other side. So we're going to go from negative 7 to 4. So then I'm going to pick back up on the other side of 4, and I'm going to go to infinity. Now, the only thing you really got to make sure you remember is I'm using parentheses, because parentheses means not included. And that's the whole purpose of the way it's notated, is I don't want those values to be included because they are going to cause my graph to be undefined because it's going to have a denominator of 0. So my suggestion for that is always to graph it on a number line using those values. All right, so transformations. So describe how this is being transformed. So I have the original graph. I have x plus 6 cubed, and it's being transformed. So I now have a negative in front, and it has become x minus 3 cubed. So I need to ask myself, how did I get from plus 6 to minus 6? So in order for that to happen, I would have to subtract 12. Okay? Now the thing about subtracting 12 is it's in the inside of that function. If it's on the inside, what I tell my kids is anything inside of a function with x. So x's, like I relate it to your actual physical x's. So you may have an ex-girlfriend, ex-boyfriend, whatever it may be. And they're your ex for a reason because they're crazy. So the way that I tell my kids to remember is anything that's inside the parentheses or with the x is crazy. So it's the opposite. And that's just because we're actually cubing that. And it's just a whole process of opposites inside the parentheses. So I have x plus 6 and I'm subtracting 12. So normally we would think about subtraction as to the left, but really subtraction means it's going to the right because it's inside the parentheses. And then we have this negative on the outside. Now, the negative on the outside is a reflection. Now the key is, what reflection is it? So if it's on the outside of the function, then it is always a reflection over the x-axis. If the negative is on the inside with the function, with the x, then it's a reflection over the y. So that's just a key thing there to remember, is negative on the outside is a reflection over the x-axis, negative on the inside. So if it looked like this, that would be a reflection over the y-axis because it's inside the function. So you got to just kind of remember that rule about reflections and the negative and where it's located. So that's the reason the answer for this one would have been C. All right, so then the next one, they give you a function and they ask you to identify whether or not it's a power function. So the definition of a power function basically means that it has any variable that has a positive whole number as its exponent. So no negatives and no rationals. So we can't have -1 because that's not a power function. Technically that would change to reciprocal, and that would become a rational function. We also can't have rational or fraction because that's going to turn into a square root function. So we always want positive whole numbers. So when I look at this function, so it's saying that I have a function of y and I have -1/5y. Well, my exponent here is a +1. If I don't have a physical exponent that I see, then it's automatically 1. Well, 1 is a positive number, so therefore it is a power function. Now, it says that the power is 1, which is what we define, and the constant of variation. So the constant of variation is what your number is being multiplied by in the front. Okay, so that is your constant of variation. So basically a constant of variation just means what am I multiplying my y values by each time. Okay. Alright, and it says describes how the transformation of the monomial, so I have x raised to the nth power, and they have this piece. So technically my original function, so I call them my parent functions. I have g of x equals x to the third power. Okay, so they're asking me, how does x to the third power change? How is it being changed with transformations to this? So first thing I notice is I have that plus 4 on the inside. So remember, it's inside, so it's the opposite of what we think it is. So this is actually going to the left instead of the right. And then we have the 3 in the front, or excuse me, the 5 in the front. So this is vertical, and I know it's vertical because it's being multiplied on the outside. Horizontal is when it's multiplied on the inside, okay? So a vertical stretch is when the number that's being multiplied, we'll call that C, whatever, any value, is when my C value is greater than 1. So if my C value is greater than 1, it's a stretch. If it's a vertical shrink or a compression, they kind of use different terms, then it's between 0 and 1. Okay, so we don't want negatives because that's going to reflect, that's going to actually change to a reflection. That's two different things. And anything that is between 0 and 1 is a shrink. So 5 is greater than 1, so therefore this is a vertical stretch. All right, and the y-intercept. So the y-intercept is the value that you get whenever your x value is 0. So when I think about my y-intercept, so here's my original function. So my y-intercept, I'm actually going to plug in 0. Oops. I meant to do that in a different color. I'm going to plug in 0. Sorry if you can hear my son, he's crying in the background. For x, plus 4 raised to the third power. Well, we know that 0 plus 4 is still going to be 4. So 4 raised to the third power is actually 64. And then 5 times 64 is going to give you that 320. And I'm just checking that to make sure we're right. Yep, so it's 320, which is where that value came from. So remember, when you want to find the y-intercept, you can either graph it, look at where it crosses the y-axis in Desmos, or you plug in 0 for the x value and solve. Sometimes it's easier to graph, sometimes it's easier to plug in 0, so you have different options. All right, and that was it of the ones that you requested. I'm going to add on a video about Desmos for some of these options. It's just that I have my iPad in front of me. It's going to be easier for me to screencast on my computer, so I'll just send 2 videos for both.